In this video, we're going to look at solving quadratics when they're in vertex form. Now notice this isn't quite in vertex form, but it's really close. For example, vertex form is going to be f of x is equal to a times x minus h, close parenthesis, squared plus k. Now this is what we call vertex form here, and it could be y equals a times x minus h squared plus k as well. But that is your vertex form. But once again, you'll notice in this particular problem, we don't have a situation where it's equal to 0. It actually says it's equal to 60. So we do have to move a term before we can solve it. So I'm going to put right here, first, set equal to 0. Now the way I'm going to do that is I'm going to use inverse operations. So I'm going to draw a line through my equal sign, and this is a positive 60, so I want to subtract it. And I'm going to go ahead and do that from both sides of the equation so I can make sure that I keep it balanced. Now that I've done that, 60 minus 60 is going to be 0. And over here, if I were to combine negative 4 and negative 60 in the calculator, it's going to give me a negative 64. And then I'm just going to bring down this over here on the left. X plus 5 squared. And so notice now this is actually in vertex form. In other words, I can rewrite this as simply x plus 5 squared minus 64. Of course, that plus sign doesn't look too great right there. And is equal to 0. So what we're going to do is we're going to go ahead and take this and we're going to solve it. Now that I move this whole thing over, I'm going to go ahead and move it over to the right. Because right now, currently, this is in vertex form. Now, some of you may be looking at it going, well, Mr. H, we don't see an a value in front of the parenthesis like you put here. Well, that's because, in this case, a is 1. There's an invisible 1 in front of every parenthesis. And so right now, it's basically 1 for our a value. And then notice we have our x. And then for our h, right, we have this 5. And for our k, we have negative 64. So once we get here and we're ready to solve it, the first thing we want to do, second, is we're going to move the constant to the right. So I'm going to go ahead and use inverse operations to move this whole term over to the right. And then I'm going to bring down what's left over here on the left. So I still have x plus 5 squared is equal to positive 64 over here. Now I just always like to start with it set equal to 0, and but you know what, some of you may have realized you could have just moved the 4 over. Well, yeah, you could have done that, but just follow these steps real quick and then always make sure you get it right. I'm going to move it up. Now I want you to think about it. What can we do to get rid of this square, right? Because we can't do anything with what's inside of these parentheses until we get rid of that squaring that's going on the outside. And to get rid of squaring, we simply take the square root of something. Now, if I take the square root of something on the left side of the equation, I do have to keep it balanced. So I want to take the square root also on the right. Do keep in mind that anytime on the right when we're solving a quadratic, if you take the square root of something, you're going to have a positive and a negative. Alright, so keep that in mind. I'm putting plus and minus right there. Now anytime that I take the square root of something that's being squared, it simply just gets rid of the squares. So notice I just drew a line through the 2. It no longer exists. All we have left now on the left hand side is simply x plus 5. And that's going to be equal to plus or minus the square root of 64. Now I do have another step that I must do. I need to go in and take this 5 and I need to move it over to the right hand side and get it away from x. Because if I'm looking for my solution, I should have x equals something, not x plus 5. So let me go ahead and use inverse operations. I'm going to subtract 5 from both sides. That leaves me with 0 on the constant value, and I'm simply left with x is equal to. Now here's where I kind of stop, and just like when we used the quadratic formula, I told you there's going to be one where you add the radical and one where you subtract the radical, because we can't add and subtract a radical at the same time. So I'm going to put a little plus sign over here, just showing that this is going to be the one where I'm adding the radical. And so I'm going to rewrite what we have right here. So I first of all have negative 5, so I'm going to write that in front. And then I'm going to put plus the square root of 64. And then we are also going to have one, and I'm going to write it over here to the right, where we're going to subtract that radical. So I'm going to say this one is going to be my negative 1. So equals, and I'm going to write this same thing over here, negative 5. But instead of saying plus, right, because on this one we added the radical, I got to do the subtraction. So it's going to be negative 5 minus the square root of 64. So really notice the only difference in these two solutions is that here we're adding the radical and here we're subtracting it. And this symbol in front of the x, it doesn't mean my x is negative and that this one's positive. That symbol is just an indicator that I use to remind myself that this is me adding the radical and this is the solution where I subtract the radical. And when I write my final answers, I'm going to leave those two little signs off. That's just to help me stay organized. So I'm going to go ahead and let's write this one, x is equal to. Now we're going to put this in the calculator real quick, right? If they ask you for an exact answer, in some cases you may not want to put this in a calculator, you want to keep it a radical, but I do recognize this is a perfect square. In other words, I know that this is actually 8. I just have that memorized, right? Because the square root of 64 is 8, because 8 times 8 gives me 64. But for those of you who may not realize that was a perfect square, you could always put it in a calculator and see if you can get an answer that is just an integer. Because if you do, there's no point in leaving the radical. On the other hand, if you didn't get an integer, you get some weird decimal strand. In my opinion, I would go ahead and then simplify the radical and leave it as an exact answer. So I'm going to type in negative 5 plus the square root of 64, and I'm going to hit enter. And notice it gives me an integer, so I have 3. So x is equal to 3, and I'm going to box it. So that's one of my solutions. And now I'm going to do the other one. Now to do this other one, much like when we're using the quadratic formula, I'm not going to rewrite this whole thing in a calculator. I'm just going to click up until it highlights it, hit enter, and then I'm going to go change that positive sign to a subtraction sign, and hit enter. And it gives me negative 13. So I have x is equal to negative 13. So I now have my answers. These are my solutions. So I'm going to put right here, solution, roots, x-intercepts, and zeros, right? All of these are the same thing. But there's my answers. Now, I am going to check it with the calculator because I always recommend checking everything with the calculator when you're done to make sure you did it right. And we can actually graph one of these. Notice we had changed this, right? By moving that 60 over to the left, we had created a quadratic in Vertex form that we could put in the calculator and graph. So I am going to make sure that I got the answer right, because you never know, right? Mr. H could have made a mistake. So I'm going to go ahead and go to y equals. And I'm going to graph this real quick. So I have parenthesis, x plus 5, close parenthesis, squared. And then I'm going to go ahead and put on there minus 64. So this is it in Vertex form. I'm going to hit graph, and you're going to see a parabola pop up, or at least part of one. Okay, you can see this clearly goes through 3, right? That's one of my zeros, and that's what I got on this solution. So at least I know I did this one correctly. Now I am going to zoom out because I can't see it. So I'm going to hit zoom and hit zoom out. I'm just going to click on it one time, and now I can see both solutions. And it does look like it's over here on the far left, right? Which would make sense because we have one of our solutions is negative 13. But if I wanted to check it with it, just to be certain, I'm going to hit clear. I'm going to hit second and trace and go to 0, hit enter. And I'm going to go over here to the left and hit enter. Click to the right until it goes below the 0, hit enter, enter. And notice it does tell me negative 13. Then I'll hit clear, and I'm going to do that one more time. So I'm going to hit second, trace, go to 0, and I'm just going to confirm that we got a positive 3 on the right. And let's see, to the left of it, hit enter, go to the right of it, enter, and notice its x is positive 3. So I've confirmed with the calculator that I did my math right, and I have x is equal to 3 and x is equal to negative 13. Those are my two zeros, are my solutions.